Hey there, I've been taking quite a long holiday, so I haven't do much since, I don't know, 2 weeks maybe. If you know, it's nearly the Chinese New Year, and yeah, I live in Hong Kong, I'm technically a Chinese, so I am having some holiday for that festival, something. I don't really celebrate, but you know, if people give you a holiday, you take it. And now, I'm back to looking at 2013, okay, HL question. So this is HL. Okay, it's the latest one. Basically, it's 13 May 2013 May. This is Samsung 1. Again, the paper is not easy at all. It's not easy at all. There are some questions that are highly conceptual. Yet, if you understand the concept, it would be quite easy. Okay, the two questions that I'm gonna do today is two of them. If you know the concept, it's easy. If you don't know, you totally have no clue. There's nothing that you can do. Okay, to tackle the question. So let's move on. Okay. What we see here is question 6. It's a short question, so 7 mark maximum. Polynomial px, real coefficient of degree 5. Okay? If you understand, a polynomial of degree 5, if you're counting all complex roots and real roots, and if you even count multiplicity, I will talk about that later, you have 5 roots. Okay? So the question would technically give you 5 roots. Okay? Here they are. Px equal to 0 have root 2 plus I, complex root 2 plus I, and we understand the conjugate, the concept of conjugate. If 2 plus I is a root, 2 minus I is automatically another root. The graph of Px also have x-axis as tangent. So if this is the x-axis, okay, the graph may do something like this. Okay, that basically means this is another root, right? So 1, 2, 3, 3 roots already. We also see that the graph would cut the coordinate axis at -1, 0. That's obviously another root with 4 roots. Is this a root? No, come on. No, it's not. This is basically the y-intercept, okay? This is point 0, 4. X is 0, y is 4. This is the y-intercept. Question. Find Px, okay? In factorized form, okay? That means you don't have to expand everything, okay? But the stuff has to be real. Okay? So cannot be having anything in I. You have to eliminate all the I's, but you don't have to expand everything. So there isn't much work to do if you can find all the factors. Well, obviously you can find a lot of factors because they have already given you 4. 2 plus I, 2 minus I, 2, and -1. Therefore, automatically, I believe everybody can do this. They would say that Px consists of these factors. If 2 plus I is a root, then x minus 2 plus I is a factor. Okay. Well, 2 minus I is also a factor, so x minus 2 minus I is another factor. Okay, 2 is a factor, so x minus 2 is a factor. And of course, x minus -1, which means x plus 1 is another factor. Everybody can do this, but first of all, this is not complete, as you can see, because the degree 5 polynomial 5 roots, and obviously if you expand this, you have x times x times x times x, you have degree 4. Therefore, one factor is missing. Second of all, it's not necessary that the polynomial have starting coefficient 1. What do I mean? I mean, if you expand this, you would inevitably get x to the power 4 with coefficient 1, right? Because there's no number in front of any x. Well, that doesn't have to be true, and the question doesn't say anything about that. So therefore, you cannot assume that this is 1, which means that you have to add another constant at the beginning. Okay, you assume that the starting coefficient could be a, which we will be able to find a out later. But the problem still remains after we fixing a. Where is our 5th root? Now, here's the question. Here is the thing called multiplicity of roots. I don't know if you know this, and I've been looking at the syllabus after I found this question up and down. I do not see this inside the syllabus. So, I don't know how you know this, but since I see this question now, I guess I'll just tell you this. Okay? If you consider the case of quadratic, okay, you can see that sometimes the graph will look like this. There's only one intersection, or we say the graph touched the x-axis at one point. Okay, then we can also say the x-axis is a tangent. Okay, which is what the question have. The x-axis is a tangent. So this is a tangent. What does that mean? Now, quadratic equation usually, this pen is screw, usually have two roots, right? 1, 2. Okay, so quadratics have degree 2 and it has two roots, so that makes perfect sense. But what happens if we have this case? If the graph have a tangent to the x-axis, then we would say that the two roots become the same root. We say this is a repeated root. And we would actually say that this root have multiplicity equal to 2. That means we kind of count this root twice. So we're gonna still say that this quadratic equation have two roots if we count multiplicity. We would count this root twice. Now let's say this root is 4. Let's say this is 4. Then what is this quadratic equation? This quadratic equation must be in the form of 4 is a factor, therefore x minus 4. But this root, we kind of say that it happens twice. So it's not just x minus 4, but x minus 4 times x minus 4 with the accounting of starting coefficient. Now let's say the starting coefficient is 2, right? For this case. Then you would see why this works, because if we try to solve this, obviously we have x minus 4 equal to 0, or the other part x minus 4 equal to 0. So both of them give you the answer 4. And that basically means we have a repeated root. Okay, sorry, miss here. That basically means we have a repeated root. And you now would know how to sketch this. You write 4 here, okay? You write 4 here, just like what we did at the beginning. So in addition to how to come from here to here, you have to know how to go backward, alright? For quadratic. This is a quadratic. So at the stretch, I can say this is still inside the syllabus. But what about higher power polynomials? Okay? Let's say this polynomial, okay, have a root here, which is say 2, and then have another touching point at the x-axis here at 4, which again, I would say that the x-axis is a tangent to the graph here at the point 4. Then what is this equation? Okay, how do we find this polynomial? Obviously 2 is a root, therefore x minus 2 is a factor. While this, if you see this shape, same with the quadratic case, I would say that this point at least have multiplicity 2. Now I would say at least because technically we only know that if you have this shape, the multiplicity is an even number. So it could be 4, could be 6, could be 8. We can't really tell. But let's say, take it to the simplest case, let's say it's 2. So I would again have something like this. I would write x minus 4 twice. X minus 4, x minus 4. So basically, I end up with x minus 2 times x minus 4 squared. Okay? And if we take this simplest case, this is basically a degree 3 polynomial. This is degree 3. So this is degree 3. Okay? Because the multiplicity is at least 2. Now, if you understand this, we can go back to our question. Now, you can see that for this case, we have the x-axis as a tangent at 2, 0. That basically means at 2, the multiplicity is at least 2. We also know that it's actually exactly 2 because the maximum degree is 5. We have 4 roots already. So if the multiplicity is 4, the degree would go up to 7, which is not possible. Okay? So we can see that we actually need a square here at x minus 2 because the multiplicity of 2 is 2. Okay? You got to really understand this. I don't know if any school teach this, if any teacher teach this. I don't know if I taught this before because I didn't think this is in the syllabus. You can try to look through it, all the pages, and tell me what you find. Tell me what you think about this. Okay? But anyway, this is how we do this. Well, let's continue doing this. Since the thing has to be in real coefficient, some I is no good. Therefore, let's simplify this a little bit. So x minus 2 minus I, x minus 2 plus I, minus 2 squared. Since this is real, I don't have to square this. You have to expand this a little bit. The fastest way of expanding this, I don't know how you would do it, is by using the identity, okay, a plus b times a minus b, okay. Do you know this? If you're HL, I suppose you know this, okay. It's a squared minus b squared. We would take x minus 2 as a and I as b. So a, b, a minus b, a plus b, which equal to a squared minus b squared. Okay, the rest is just the same. So x minus 2 whole square. Okay, I suppose you know this again. Okay, this is even simpler. A minus b whole square is a squared minus 2ab plus b squared. Okay, minus I squared. I squared is -1, so minus -1 plus 1. Okay, 2 plus 1. We simplify this a little bit. Okay, so this is in factorized form, they're in factors, and they are also real. Everything is real here, except I have to find a as well. Okay, how do you find a? You may have noticed there is one point that we haven't used at all. The y-intercept for 0. 0, 4. So I think it's pretty simple how we use this. We just plug it in, right? So we plug x as 0, 0, 0, 0. The y-intercept would be 4, okay? So we got this by plugging in 0, 4. So this is 4, 1, 4, and 4 cancel out. So a is 1/5. A is 1/5. I believe you can do this on your own if you understand what's going on. So we have got px is 1/5, x squared minus 4x plus 5, which is copied from here, x minus 2 whole square, x plus 1. Factorized form, real coefficient. I also considered the leading coefficient. That's 7 marks, okay? So if you understand the concept of multiplicity, you would have, never hesitated to put a square here, and then everything just went through. At worst, you just miss the a part, the leading coefficient. If not, I don't know how you do this, okay? Because you would have struggled at, I'm missing the 5th root, and you wouldn't dare to write anything at all. I bet you just put down the 4, and then maybe you get 2 marks. I don't know. So this is it. Okay? Again, it's New Chinese New Year. Wish you have a good holiday. It's starting of another new holiday, new year. And in Chinese, we have a saying that everything starts at spring. So everything is new in the new year. So I hope you have a new plan, new resolution for the coming year, and maybe do more math.